come to the first part of time series forecasting. As we know that the forecasting has a lot of methods, but let's discuss about the time series.
Let's discuss in detail about the time series forecasting. This is part of the module of forecasting. The first method in the time series forecasting is, we call it this is the simplest one. We call this method is a naive method. What is naive method? This method assumes that the demand in the next period, so demand for the next period, is exactly the same with the demand in the most recent period. For example, the demand for 30, for the next day, this is 30 May, is equal to the demand the 29th of May. So the demand in 29th of May is 489. So the demand for the next day is 489. This is also applicable, when we try to forecast the demand for 31st of May, for example. The actual, when we already knew the actual demand for that day, so this one becoming here 481, this is actual for 30, become the forecast for the 31st of May. And this is also applicable for the others. So this is the naive method. This naive method is cost effective. This is the efficient way, simple one, and might be has a good performance. This naive method can become a good starting point for others method. Let's discuss the next method in time series forecasting, that we call it the moving average. The moving average is simple technical analysis tools that smooth out data by creating a constantly updated average price. Previously, we just copied from the most recent period, only one that we copied, and become the estimate of the demand. Now, in moving average, we average several data. So the situation could be like this, and this situation we got this blue line by averaging the 50 days, for example, 50 days before. This moving average is mostly used for smoothing, and this is best if there is no trend happen. If there is no trend happen, this is good to use. For example, in this figure, there is no trend actually that happened. This is constant, just up and down like this one. So this is best to use the moving average. In moving average, we use the constanta of n that smooth the forecast, but it makes less sensitive to change. So the constanta of n, it's mean number of moving average, or moving average number. It means how many period that we should make an average. If we use 3 period, 3 period before, we average 3 days before or 3 months before, 3 months before, it means n is equal to 3. Take a look at this example. So the moving average is equal to sum of the demand in the previous n period, n period, divided by n. So we just took an average. So when n is increased, it means n is increased. For example, we try to increase n to become 10 or even 50, like in this figure. So the data is tend to become flat, or near flat. But when we decrease the n in here and the n constant in here, the data is becoming sensitive, the forecast is becoming sensitive to change. So it's tend to follow the pattern in here, follow the pattern. For example, there's another example of the moving average. When we use n constanta of 3, so 3-month moving average, we call it. So we can simply, for example, we want to forecast the demand in April. So we use the data from January, February, and March. So since we use 3 months moving average, we average those 3, 10 plus 12 plus 13 becoming 11 to 3rd. So 11 to 3rd is the forecast for month of April. We can use the same calculation for the May. If we calculate for May, for example, and then we should use a data, the actual sales from February to April. So 12 plus 13 plus 16, 12, 13, 16 divided by 3, so 13 to 3rd, becoming like this. The next method that we want to discuss in here is we call it the exponential smoothing. This is the technique for smoothing time series data using what we call it the exponential windows function. In simple moving average, the past observations are weighted equally. Exponential function in here is used to assign exponentially decreasing weight over the time. This is the formula of the exponential smoothing, where this is the constanta. We can simply represent as A, or we can simply represent as alpha. We can do that. That is, this constant is ranging between 0 to 1. If we use this constant of 0 in this case, so it means if the A is 0, it means that the forecast for the next period is equal to forecast with the previous period. When this is 1, so the forecast of current period should be equal to actual of the previous or the most recent period, which is equal to naive method. It's like this. So A is here is smoothing or weighting constant. So in this figure, explain and illustrate the effect of alpha or A in the previous formula, alpha or A in the previous formula. When alpha is equal to 0.1, this is small enough, the forecast is tend to be flat, or we call it or insensitive to change. But when we increase the alpha, the forecast becoming sensitive to change. Next method that we will discuss is what we call it the seasonal. In seasonal, is handle time series factor of trend and season. So there is a trend and season that we not yet discussed before, not yet handled by the previous method before. So we forecast monthly sales, for example, we want to forecast the monthly sales by multiplying the estimate sales for the next year by the seasonal index for each month. So each month we have the seasonal index. For example, this is the seasonal index for the month 1. January is here, January. This is February, and so on and so on. We represent this fluctuation into what we call it the seasonal index. In seasonal, this consists of the additive. The seasonal amount is a constant, so just simply add it. Demand plus seasonal factor, and multiplicative. It means the seasonal factor is embedded inside the the demand itself. So demand multiplied by some percentage of seasonal. The hot winter forecasting is one method to model and predict the behavior of sequence of the values over time. Yeah, the hot winter is also called triple exponential smoothing. Why we call it triple exponential smoothing? Because we see this is the hot winter formula. The number one, this is number one. This formula is the same with the exponential smoothing as you see in here. And the second one, when we embed the trend, the formula is becoming like this. We embed the trend. And the third one, we embed another factor that we call it the season. Yeah, season in here. So the forecast for the next season is becoming like this. This is the whole winter formula or triple exponential smoothing. So we smooth 3 times. Yeah, smoothing with alpha, smoothing with beta that represent the trend, and smoothing with the gamma that represent the season. So alpha, beta, gamma is the smoothing variable. So thank you so much for joining me discussing about the time series forecasting. In the next video, let's learn about the associative forecasting. See you again in the next video.
Thank you so much for joining me in Learning Operation Management. See you again in the next video.